do worms and humans have in common? What if I told you both could regrow their brains, like not just at birth as previously thought, but throughout their entire lifetime?
Growing a brain cell as an adult is a lot like growing a plant. First, we'll need some soil. I think I'm gonna go wash my hands.
Our soil lies in the subgranular zone, or SGZ of the dentate gyrus, part of our hippocampus, and is filled with extracellular matrices, blood vessels, macrophages, microglia, and so much more.
I know that was a lot, but think of them as fertilizer, only there to enhance the growth of our seeds, or precursor cells.
Just like how you don't plant a mango seed expecting to grow an apple tree, precursor cells are just blank cells that can only turn to one cell type, a process known as unipotent differentiation. Let's call our seeds type 1 cells. As they divide asymmetrically, they turn into types 2 and 3, and they proliferate a lot to maximize their chances of survival. This is the precursor cell phase.
Next up, the early survival phase. Remember these itty-bitty neurons? Well, they're competing with huge trees or adult neurons that already exist in the dentate gyrus, so a lot of them will end up dying off. Those that survive are called neuroblasts.
Neuroblasts send an axon, or root, to the CA3 region guided by crimp, a molecule that acts as a compass.
Next up, the postmitotic maturation phase.
Our seed begins to grow several branches that reach above the soil called dendrites. Like leaves searching for sunlight, dendrites search for BDNF, a protein that merits a healthy neuron. This sunlight, however, is limited, and the immature neurons that don't get some end up dying off. Likewise, the axon competes with existing neurons in the CA3 to form connections called synapses, to finally communicate and integrate within the brain during the late survival phase.
This, ladies and gentlemen, is adult hippocampal neurogenesis. An unlimited supply of brain cells, right? Not so much.
Of all neuron types, you only create adult granule cells.
And we can't say for certain how these new neurons actually make a difference, but we are on the right track.
The hippocampus is often the first to be affected in diseases like Alzheimer's and epilepsy.
So harnessing AHN could very well lead to breakthroughs all across neuroregenerative medicine.